Hello again, everyone. Hello. Hope you're all well. Hope this video finds you all well. Great. Okay, now we're moving on with our Arduino series in C++, and things are going to start getting a little bit more challenging. Yeah, not complicated, but challenging. All right. We are going to build a security light. Okay, a security light. Okay, let me just take you over to our pinouts. Today we're going to be using analog pin 0, just here. Hope you can see my marker. Yeah, you can. And GPIO number 10. Right, GPIO number 10. Okay, we're going to be making a security light. We're going to be making a security light. Okay, and today we're going to be using a small component called a photoresistor. Let me just get this so you can see it. A photoresistor. Can you see that? There's only one in your kit. Okay, there's only one in your kit. Can you see the little lines going across? All right. Oh, just a reminder, if you haven't got your kit yet, okay, I have got a link below for the Sunfounder website. Okay, just go there and you'll get everything you need. Get everything you need. Okay, and we need an LED. I'm going to use a blue. All right, and you're going to need a 2 resistors, 200 or around 200, 220 for your LED, and for your resistor a 10k. You need a 10k resistor. All right. So should we build the circuit? We'll do one circuit at a time. I think the first one we'll do the blue LED. Just move some stuff out of the way. So there's my blue LED. Let's go to the schematic. That might help. Won't come up. What's the problem here? Just recently, I've been having a lot of trouble with my what's it called? Portal software. So hopefully won't have much more. So there's my blue LED. Put the right leg, the long leg, remember it's got a long and a short leg, put that on the right hand side. All right, get it in the holes. Yeah, so that's the blue LED. I'm going to take the blue cable from the right leg, yeah, and I'm going to go to pin GPIO and number 10, as I said earlier. All right. Then I'm going to get my 220 ohm. I've got a 220, 200, 220 ohm, just around there. And then I'm going to go from the left leg of the LED across. And then I'm going to take a ground, black. So let me just take that back one. So it's all, I've got a space. Yep, there. Then I'm going to take a ground from the left leg of the resistor to my ground rail, like that. All right, so that's the circuit for the LED constructed. Now this photoresistor, it's got 2 legs, but they're the same length. See that? So I'm taking it that it doesn't matter what way round it goes in. So let's put that in to the breadboard. All right. Now I'm going to take a yellow cable. Sorry, let's put the resistor in first. Let's put the resistor in first so you can see that. Remember, it's a 10k resistor. go to the left leg of the sensor. All right, the left leg of the sensor to a different column, like so. Right, and the same leg, right leg of the resistor, left leg of the photo sensor goes in, and that goes to analog 0. See that? See that? And then I'm going to take the red from the right leg of the photoresistor to 5 volts. Remember, my rail up the top here is 5 volts. So I'm going to put that in there. Actually, I've done this wrong. Let me take the left leg of the resistor, put that in there, put that in black, into a ground. All right. And then I'm going to use a red cable, same as the schematic, because I like to use red for power. Take that to 5 volts. All right. Okay, so that gives us our circuit. Right. Shall we go over to our Arduino? I've started a new sketch. Okay, I started a new sketch. Let me just, so you can see it a little bit better. There you go. Started a new sketch. If you don't know how to do that, it's File, New Sketch. Okay. And if your board isn't automatically picked up, and you know if your board's picked up here, you need to activate your board. Normally, once you used it once or twice, it should bring it up. Right. Shall we crack on? And let's do our variables. We've got 3 variables. First one's int. Okay, input equals capital A 0 semicolons. All right, that's for our A0, labeling our analog port to A0 semicolons. Int LED capitals, and that equals, and that's on pin 10. Semicolons, enter. Int. Now we have to set a sensor value, a variable for the sensor value, and 0 is going to be its starting value. So sensor, right, value, all small case on this occasion. Okay. That equals, 0 semicolon. Right. So that's our 3 variables. A0, pin 10 LED, and sensor value. Let's go to our void setup. Just come down on my notes. Okay, on this occasion, we're going to be using the serial port. All right, we're going to be using the serial port. So we need to do a serial.begin, capital S. Begin. All right, and we have to set the baud rate. Okay, the baud rate, that's the speed at which they communicate. All right, so it's brackets on. And we're going to be 9,600. Come outside of the brackets, semicolon. All right. Okay, so that starts communication with the serial port. We need this to read the value, of our sensor. All right, our photoresistor. Enter. Pin mode. brackets on. All right, makes it a function. LED, comma, output. All right, come outside the brackets, semicolon. All right, it's making our LED an output. All right. Right, let's go to our void loop. Come down. Right, our void loop. This starts the void loop, the curly bracket. This ends the void loop. All right. First thing we're going to do is the sensor value. All right. Sensor value equals, it's an analog read. Capital R on the read. Brackets on. See it change colour, loves it. All right. And it's going to be an input, all small case on this occasion. Come outside of the sensor value, brackets off. And it's semicolons. Enter. So we've done our sensor value. Right. Next, because we want to see the values on the serial monitor, we're going to have to do a serial dot print capital S on the serial, brackets on, quotes, what we want to, and it's sensor value. All right, space equals. Now looking at this, I'm sure that should be a serial print line, so I'm going to try that. If not, we'll change it. It might be on the next line. So serial.print ln, right? And I'm going to put a space in there, couple of spaces, all right? Enter. Then it's going to be a serial.print, capital S, comma, and it's sensor value. All right, come outside the brackets, semicolon, enter. Now, so what this does is sends the value of the photoresistor as a number between 0 and 1023, 10, 30, 23 to the serial monitor. Let's do a little bit of space. Let's bring it up. Okay. And now we're going to put an if statement, if command. All right, sensor value. Sensor value is less than 512. Okay, brackets off. No semicolons. All right, no semicolons. So what's that saying? What that's saying is that if the sensor goes below 512, the value of 512, curly brackets on, this is what I want you to do. All right, this is what I want you to do. Digital, right, capital W on the right, brackets on, makes it a function, LED, comma, high. All right, so that's telling it to do, semicolons. If the sensor value goes lower than 512, I want you to turn on the LED. I'm going to do, I'm going to just make this a little bit more so you can, it's more legible. Take that there. Bring that back. Okay, so that's our if command. We've now got an else command. Enter. Enter. So what it's saying, if the sensor value is not lower than 512, all right, if it's not, okay, else, curly brackets, enter, okay, digital right, capital W on the right, brackets on, okay, LED, comma, low, all capitals. Come outside the brackets, semicolon. All right. Oh, let me come down. That closes the else command. Come down, and we'll put a delay in here. And 50 milliseconds, semicolon. All right, so you can see what we're doing here. Right, we've set up the loop, we've set up our values, right? And if it goes lower than 512, turn on the LED. If it goes below 512, turn off the LED. Basically, that's what the code's saying. All right, I'm trying to keep it simple. Old saying in the army, keep it simple, stupid. We just need enough that we can communicate with our children and grandchildren, that we understand. Okay, let's verify. Let's verify. Right, serial.print. Sensor value. Before serial compilation error. Let me just check that. Okay. What I'm going to do for now, I'm going to take that LN out. Serial.print. Sensor value equals serial.print sensor value. Sensor. I've got an E in there. Right, I'm going to put the LN back in here. Sensor value. Okay, let's try it again. Let's verify it. Exit status, serial. Serial. Right, let's get rid of that. Just for now. Let's verify it. No, what's the problem? Semicolon. What a wally. What a wally. Right, let's try this now. Verify it. Okay. What a schoolboy error. We'll get there. Okay. Okay, looks okay. Let's go. Let's upload it. Compiling sketch. Wait for our green line. And there we go. Okay. Let's go to overhead. Are we ready? There we go. Take it away. Then put it out, cover it. And there we go. Now, what I want to do, let's look at the serial monitor. Tools. Serial monitor. Takes a little while to connect. Okay. Let me show you. I'll do that again. Tools. Actually, what I'll do, I'll close the serial monitor. Right. Okay, sorry about that. I jumped the gun. So we go Tools, Serial Monitor. It will connecting to Arduino Uno on COM3, and there we go. You can see our values. If I cover it, you'll see them change. Okay, and I'll put it right over. So I'm going to take my hand off a little bit. We're on 2 something. Take it off a little bit, goes to 3. Take it right off, goes to 6. Okay, it goes to 6. And that's our security light. Security, just like the ones you see on the side of buildings. When it goes dark, it lights up. You see it mainly around warehouses and places like that. All right, and street lights. Okay, street lights have got a sensor on, and when it gets dark, the street lights come on. Okay, great stuff. Okay, great. You know how to save file, save as, name your file, same as any other computer file, save as. All right, hope you enjoyed the video. So they are going to get a little bit more complex. I think next we'll look at playing with a potentiometer. All right, we'll look at that. All right then, but I'll see you in the next video, and thanks very much. Bye bye.